In the previous episode, we saw a demo of purging and recreating containers on the fly. That is one of the most basic needs of a Devlab, and in this episode, we will see how we do it. As we have selected to start the Devlab series on Proxmox virtual environment in this season, our service instances can be either a virtual machine or container, which are the services that Proxmox support. Luckily, the community.general collection in Ansible Galaxy provides a few models for managing virtual machines and LXC containers on Proxmox. Let's have a look at these tools. We are on the documentation page for the community.general collection in Ansible Galaxy. This collection includes many models that we can use to manage multiple systems. For example, if we want to interact with GitHub, with GitLab, which are things that we will do later in this series. We have also many other things that we can do. We care about the Proxmox models for now, and we see that we have multiple models for managing multiple things in a Proxmox cluster. Today we care about two of these. We care about the Proxmox model and the Proxmox VM info model. The Proxmox VM info model allows you to get information about running guests in a Proxmox cluster. If you supply a VM ID or a name, for example, you get information about a specific guest. If you supply a type, for example, either QEMU or LXC, you get information about all guests of that type that are running in Proxmox. And if you don't supply anything, you get information about all the guests of all types. The second model that we will use is the community.general.proxmox model. And this model is designed to manage LXC containers in Proxmox. And here we have also the connection information parameters and multiple other parameters that we will use many of them today. Let's start creating our Devlab automations. On the left side of the screen, you see that I have my Proxmox installed that will simulate my main lab. And here I have my Ansible controller, the Debian-based Ansible controller that we created in the previous episode. And on the right side of the screen, I have VS Codium. And here I want to connect to that container. I know the IP because of the way I have automated my Devlab. So I know the IP is 168.1.221. The IP that I use here is the same IP, the same ID that the container has in Proxmox. So if I connect now, I am inside my new container. You see, you see the IP here, and let me adjust this here. If I see I am in my home directory, and I think I have already created the Devlab code folder. So this is an empty folder. I can open the Devlab code folder, and it is an empty folder as you see. The first thing we need to do is to make sure that the Ansible collection community.general is installed, and we have seen that it is installed. This is the command that you can use. We have seen that it was installed from the previous time when we prepared the Ansible controller. So the second thing I need to do is to create two folders. I want to create a folder for my variables because I like to structure my variables based on the host that they are targeting, and I want to create a roles folder where I will put all my roles. The first role I want to create is a role to purge an existing container. So if I go to roles here, and I issue the command Ansible Galaxy init, and I'll call the role BVE purge. The Galaxy creates like the entire structure for a role. All these might be required for in some situations. For example, here you can define defaults for the role. What we care about now is the tasks folder, and here we have the main tasks for this role. First, we check with Proxmox to see if the VM ID that we want to delete exists. or no. If the VM ID does not exist, we do nothing because it's already deleted. If the VM ID exists there, we decide whether it is a LXC container or a VM. And in both cases, we use the appropriate models to shut down the container or make sure it is down, then we remove it. The first task is common between both containers and VMs. So the first task would use the Proxmox VM info model. And here we need to pass the node and the host and the username and the password and the VM ID. And we record the result of the call in the guest info variable. To do this, we need to prepare our variables. We need to define our variables. Under vars here, I can create a new variable file called bve.yaml. And I call it bve because I like to structure my variables based on the type of the host. So in my bve variables, I'll copy also some notes. So I have like my BVE, this BVE that I'm connecting to is running on 220, and the host name is Proxmox, which is what you see in here. Next, we need to define the passwords, and for the passwords, we need to use to treat them as secrets, and for that, we create a new folder called vaults. And in these, wrong, rename, vaults. And here we create a new file called vault.yml. Now, a very important task we need to take care of before we put any secret in the vault is to exclude this vault from Git. So that's why we create a new variable, a new file called gitignore. And we ignore the vaults folder so that when we create a repository, when we initialize a repository, we do not include this vaults here, but it may be interesting to include a vault template file that we can include in our repository. And here I can use my username and password for this install of Proxmox, and I will put them also in the template. Note here that when you authenticate with Proxmox, you need to specify the authentication provider. So my name is root, and I'm using the PAM authentication, which is the system authentication on Proxmox. So now I have 4 of the variables prepared for my role. I need to test it to see what results I get for this role. So let's try creating a new file here called bve purge.yaml. And I'll use the vars files, vars/bve, which is this file, and vault/vault, which is this file. Those define 4 variables that I need for my role. And what remains is a 5th variable, which is VMID, that I don't want to put a default because I do not want my role to delete anything by default. So now we can test this role if we go up a little bit and we issue Ansible playbook bve purge. And because I want to test it, -e vmid equals, let's give it 222. Let's get information about the other container that we have. And we pass -v so that we see the results that we will get. So this is the result that we got from Proxmox. We got a Proxmox VMs object that contains an array of objects. And in this object, we care about the type here. You see, the type is LXC. So we get an non-empty array. We have an object, so we know that host exists. If I pass, for example, host 223, I do not get Proxmox VM. I got an empty array. We get back and to look at Proxmox VMs, VM222, and we see that the type is LXC. So I know that I need to check the first element in the array and on the top based on its type. So to delete a VM, let's start with the VM now. In my roles, tasks, I want to create a new file for deleting a VM. So purge QEMU.yaml. The algorithm is pretty simple. Stop the VM. Then we give the VM some time to stop. And without this, like based on my tests, I found that like the entire role will fail silently. It will not give you an error, but it will not shut down the container. And if it is not shut down, you will not be able to purge it. So I give it 5 seconds to shut down. And we issue this only when VM stopped, when the VM was stopped. Then I use the same role again. You see here I use state stopped, and here I have state absent. The second task I will do is purge lxc.yaml. And here we use the same algorithm, but with the Proxmox, not the Proxmox KVM model. The model here is Proxmox. Now, in my tests, I found out that in all situations, when you try to stop an LXC container, Proxmox will stop it always. It will not return until the container is stopped. So now when we have our dependencies ready, we can use them, call them from the main role. We check if we have anything in that array in the Proxmox VM. You see guest in for the Proxmox VMs, which is this object here. If we have anything in here, and whether that thing, we check the first variable, and the type of that first variable is QEMU. We include the tasks purge QEMU. Otherwise, we include the task for purge LXC. So now our role is ready to execute. And if we execute it again now, if we execute it, we will be deleting the container 222. Let's try that. So container 222 is gone now, and now we have a working role. The next automation on our list is a role to create an LXC container. And we start by creating that role. So let's close all these, and we cd into roles. And we create the role structure, Ansible Galaxy init BVE LXC create. So now we have under roles, we have LXC create and LXC purge. If we look at the documentation for the model, the Proxmox model, we see that we have many variables that we can provide, many parameters that we can provide to the role, and choosing what parameter, it depends on your setup. For example, sometimes people would try to get all to standardize on using OS type Debian, like what I do. Sometimes people would supply a public key that like we would do for our so that we can automatically connect to the container directly without any changes using SSH. These roles depend, these options, these parameters depend on what you want to do. I'll show you also the full documentation of what you can write here. You can see it in the Proxmox API Explorer, and here are all the format of all the variables that you can use with description about them. For example, when you define networks, this is how you can write the network, like the detailed explanation here, all the variables. How when you want to create a volume, when you want like it's all all the details about the format and the reference for the Proxmox API. So what I have done is I have selected some of these variables and used them in my role template. Which ones you select depends on you and what you want to do yourself. The first parameter we will define is the password for the container, and this one I will add it to the vault template and to my vault as well. I'm keeping the vault unencrypted because I'm still working on development. Like normally you should have the vault encrypted according to the Ansible documentation. Then I will bring more variables that I will set for my Proxmox containers, and I will put them in the PVE variables file. So the first, I'm defining the container template, which is the Debian standard 12.2, and I have already downloaded that template. So you see I have templates here. I have the Debian and the Fedora templates. I downloaded them from the templates service in Proxmox. So I have both of them now. So the first variable I set is the template. Then I want to standardize on 2 cores for every container, unless I decide to change that when I run the role. I set the memory of in 1024, 1 gigabyte of RAM for the container and 4 gigabyte of disk for the container. I store it in the local storage, which is the only storage I have. It's here, the local storage. And I define public keys. The public keys we will use when you connecting to the network. And here I am passing 2 public keys. The public key for my Ansible controller, which is a system. This is not this system, another system that I use to create these things, and the SSH key for my desktop, which is the SSH key that I'm using to connect to this container from here. So this container was created with this public key for SSH. I define the networks, and for the networks, since I don't know the VM ID, I leave the defaults like this. I want my containers to be unprivileged by default, and I want them to start automatically by default, and I want them to be started when I create them, so that Proxmox will start them, and I configure the name server to be my network, my local network name server. Here you can put anything. You can put quad 9 or quad 8 or anything you want, as long as your router can route the connection to it, and we will do all that later on. So let's start creating the tasks in the role. If I go here, I see that I need only 2 tasks. I need the first task to create the container, and I'm passing the variables as we have seen, the same variables. And we see some, for example, I like to give them swap 0. I don't want any swap in my containers, and I hard code also this one, nesting 1, because I don't want to change it. You can add more parameters here, and you can make these like variables if you want. It depends on what you need. So the second one will start the container. If it did not start already, it will make sure it started. And I added a handler here so that just to show you, like, it's not required. So just to show you how we can do handlers and things that we want to do when the role is executed successfully. So this would be my handler. Wait for the container to be executed, and it's 1 second only. So now my role is ready, and I can test it. So let's create a new file. We call it pvelxc create.yaml. So as you see, like, we have a name, and we define it's running on localhost, and var files. I define the same variables after I extended them. And now I want to delete the container if it exists and recreate it again. So if I test this, let's clear here. First, I need to go up a little bit, and then I need, I need to show you something here with in this role, there is a host name variable. Like this role requires two variables that are not set by default, the VM ID and the host name. And I do not want to set them because I do not want to create like variable container that have no host name or generic host name. So when I want to run this role, I need to provide these two variables on the same time. So let's do that. Ansible playbook pvelxc create, and I pass two variables now. VM ID is 222, and host name is test1. And let's see what happens. Try to purge. There is nothing to purge. Creating the container was created. Starting it, running the handler, it all worked, and we have a new container called test1. This is a Debian container because the default template that I used is a Debian template. It's if we want to create a Fedora template, we can override that in the role here. So let's see, I want to create a Fedora template. So I'll extend this role here with vars, and I'll bring the variable. The variable I have is this one. I will put it in here, and I will bring the template from my notes. So now let's run the same role again with the same variables, VM222, and 222 is gone, and it was recreated using Fedora. So now we have a role to create container, we have a role to delete a container, so we can recreate our containers when we need. Let's discuss some troubleshooting ideas. So first I'll clear here. And then if I want to change the host name only and pass underscore to the role and run the role again, the container was merged, but we failed to create it. And if you read the error message, it says parameter verification failed, VMID 222. So this is misleading because we tested this parameter ID multiple times today, and it worked fine. So there is a parameter that failed, but it's not the VM ID. You need to be careful with this error message, with this specific error message, because what fails verification can be any other parameter. And in this case, the parameter verification failed because it's not an allowed host name according to an RFC, an old RFC 952 or something. I'll put the link in the description in the article. So this would be one of the reasons that a parameter verification has failed. We can try. I'll remove it and recreate the container again, and you see like the power of automation now. Like we can recreate containers as we wish. So now the container is created and it started. It's ready to log in. The new container. There are other issues. For example, if you want to give it to give your container a static ID and you do not use the CIDR notation, for example, /24, you get an error, parameter verification failed. If you pass a MAC address, for example, and the MAC address is wrong, it's not in the correct format, you will get the same error. If you, for example, if you pass DHCP 6, if you use an IPv6, you want to pass to create a container that uses IPv6, and you do not have an IPv6 DHCP server, and you tell the container to use DHCP 6, it will fail. So there are many reasons why this might fail with you. Another interesting idea that we need to discuss is automated testing. So this is code, and untested code is bad code. This is what I think. Any code that is not tested using unit tests is bad code. Ansible uses a test framework called Molecule. And for Molecule, we do not have right now a test framework for a test driver for Proxmox. There is an experiment, I will link to it in the article. However, that experiment is still experimental and it covers only VMs. It does not cover LXC containers. So right now, we do not have the possibility to do unit tests in Molecule for our roles on Proxmox. Although like we should do unit tests, I think that is fine for now because all the code that we are writing is for our internal use. It's not the code that we will ship and deliver to anybody else. This is specific to our Devlab. So I will pass on it. In the next episode of the Devlab series, we will design our network infrastructure. And we will start by designing and creating an operational router based on the Linux kernel. We will use Debian as our router. This will not be a complete router, but in the episode after that, we will have a fully functional, fully automated, totally complete router based on MikroTik's Router OS. So please subscribe and follow the series so that you don't miss the next episodes.